Hello, welcome to this video. This is lesson 4 on sector of a circle, and in this video I'm going to talk about the length of the arc of a sector. Length of the arc of a sector, and the length of the arc. Let us do our introduction and the formula. A sector usually has a two radar, that is, this is one radar and the other radar, and then from this part, the point at which the radius join or touch the circumference from this place down to this other place is what is called the arc. And then we are finding the length from this place to this place. That is the length along this part of the circumference of the circle. Now, if we extract this out, we are going to have a sector of this form. This is the radius, and this is the angle that the sector subtends, and this is the length of the arc. The distance from this place to this place is the length of the arc, and this length of the arc is equal to, is the same as what? Theta over 360 times, since the length is along the circumference, so we're going to multiply it by the area, by the circumference of the circle, which is 2 pi r. So this is what we are talking about now. Now, to get the area, to get the length of the arc is what is just what we have got done now. Is just for you to, that is going to be theta, since the length is, since the radii we have here subtend an angle, so the angle will be what, as the theta there, and then over the total angle of a circle, which is 360. Then since the circle is along the distance, so since the arc is along the circumference, we are going to have 2 pi r. So this gives us the length of the arc of a sector. So, and then we are going to use it to solve two problems in this lesson. So we are going to do lesson 1 that says, what is the length of an arc which subtend an angle of 60 degrees at the center of a circle of radius half meter? This is a WAEC question. Let us solve it quickly. It's going to, the theta here is 60 degree and the radius is half meter. So the length of the arc is given by the formula of 3 theta over 360 multiplied by 2 pi r. Now our theta is 60, our theta is 60 degree over 360 times 2 times our pi. We can use 22 over 7 as our pi, times the radius is half meter. At this stage, we can simplify to make it easier for ourselves. 0 go with 0, 2 here can go with this 2, and then 6 can go into this number. 6 into 6 is 1, and 6 in 36 is also 6. And then we can also simplify this 6 here, can give us 6 into 2 into 6 is 3, and 2 into 22 is 11. So we are now left, at this point we are left with 11 over 3 times 7, which is 21 meter. If you can leave it like this, or you divide it to finally have an answer that will give us 0.5 to 0.52 meter. So we can leave it in this form or in this form. Then we are going to the next question that says, in terms of pi, what is the length of an arc which subtends an angle of 30 degrees at the center of a circle of radius 3.5 centimeter? So our theta in this question is 30 degree, and our radius is 3.5 cm, which we need to convert it to an improper fraction. That will become 2 times 3 is 6 plus 1 7. So we are going to have 7 over 2 centimeter. So our length now, length of the arc is going to become theta over 360 times 2 pi r. This is going to give us theta is 30 degree over 360 multiplied by 2 times the pi is so since we say that we should calculate in terms of pi, that means our pi is going to remain pi times our radius, which is 7 over 2 centimeter. So we are going to do 0 going to 0 here. So we are now having a 3 can go into this. So 3 into 3 is 1. 3 in 36 is going to be give us 12. 2 here can take this 2. And then we are now left with 7. That is 7 times pi. So we are now left with 7 times pi, which is going to give us 7 pi over this 12 centimeters. So since they say we should calculate it in terms of pi, we are going to stop in this form. So this is our the length of the sector of the length of the arc of the sector is going to become 7 pi over 12 centimeter. So the next question here is this one. We are calculating angle of a sector subtended by an arc. Angle subtended by an arc. Now, what angle does an arc 5.5 cm in length sustained at the center of a circle of diameter 7 cm? So here we see that this question is different from the one we have got solved. We are going to, because it's something of this form. The radius, the diameter is given to us as 7 cm. So we are in this question now we are actually finding this angle, the angle that this arc, and this the length of this arc is 5.5 centimeters. So we are actually not we're actually not finding the angle. We are finding we're not finding the length of the arc in this time around. We are finding the angle that is subtended by the angle by the sector. So we are going to do it this way. Theta is not known. We are finding the theta, which is our angle. The length is given to us as 5.5 cm, and our diameter is given to us as 7 cm. That means that, and diameter is our radius. Radius is equal to diameter over 2. So we are going to have diameter is 7 over 2. So that means that our radius is going to be 7 over 2 centimeter. Then let us find the length. Now the length is going to become theta over 360 degree times 2 pi r. Our length is given to us as 5.5 centimeter, which is equals to the theta in this problem is what we are finding. So theta remain. Then we are having 3 over 360 times 2 times our pi is 22 over 7 times radius, which is 7 over 2 cm. Now let us simplify. 7 take 7, 2 take 2, and then we are now left with 5.5 cm is equals to 22 times pi. 22 times theta is going to be 22 theta over 360 degree cm. So this is what we are now, and we are going to do cross multiply like this. Is going to have a 22 theta times 1 equals to, that is cm, times equals to 360 times 5.5 cm. Since we are finding theta, we want to divide both sides by these 22. That is 22 divide here, and here divide by 22. So 22 go with 22, and then we are now left with 22 cm, 22 cm. So cm goes with cm, and then we are now left with, so theta is going to become 360 times 1 point times 5.5 over, if you multiply 360 by 5.5, it's going to give us a 1980 degree over this 22. This is going to give us, divide this, is going to give us 90 degree. So the angle subtended by the arc of 5.5 cm is actually 90 degree. Thanks for watching this video. Please subscribe to the channel for further videos. Thank you.